Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 16 physics series where we are discussing each and every chapter. We have started with all the second PU chapters. Today we are going to complete the book 1 of PU2, and this is the final chapter of book 1 of PU2. And if you are wondering, we have already completed all the other chapters, and from tomorrow onwards we are going to start ray optics. That is the first chapter of book 2. So if you wondering how you can get all the questions, all the topics, it is there in our channel. You can check all the videos from one single playlist. I will share the more detail about it in the end of the video. But first and foremost, what you have to do, you have to join our WhatsApp channel. The link is given in the description. Here you will get all the updates whenever we are dropping a new video, new concepts, everything you will get an update here. Now today we are going to discuss the smallest chapter of your second PU, electromagnetic wave. Even though it's smallest, every year one question comes from this chapter, so you cannot ignore that. This is going to be a brief video. Here we are going to discuss entire concepts of the chapter as well as PYQ. So it will be a combined chapter plus PYQ session, where first we are going to discuss all the concepts, then we will finish up all the PYQs as well. So once everything is done, then you can say, okay, this chapter is completed. So don't go anywhere. Be with me to complete this chapter, and trust me, if you complete this chapter, you will be able to answer one question for sure. Now let's start with the list of contents. List of contents is very small. First we will start with displacement current, which is a theoretical concept. Next is speed of light, very important. Then electromagnetic waves. Here we are going to discuss everything. For example, how the electromagnetic wave is produced, electromagnetic spectrum, everything will be covered in this part. Then we will solve previous year questions. Then you can go home and you can relax. Now let's start with displacement current. Displacement current concepts is very unique and very important. Before we start, let us understand what is the meaning of normal current that we have studied in our current electricity chapter. So we have a conductor, okay, and electrons are flowing through it. The circuit is completed. There is a battery, okay, and the current is flowing from positive terminal of the battery to the negative terminal of the battery. So and electrons are flowing from negative terminal to the positive terminal. So this is how the current flows. This is called conventional current, or IC. This is called conductor current, okay, sometimes also called conventional current, conductor current, IC. Now suppose what will happen if I disconnect the circuit. Suppose I disconnect the circuit from this end. Will the current will continue to flow? Obviously not. The current will not flow because the circuit is now broken. We call it a broken circuit. So in this case, current will no longer be flowing in the circuit. Now what will happen if I connect a parallel plate capacitor? Suppose I connect a parallel plate capacitor here. Now what will happen? Now parallel plate capacitor has air gap between them, right? So ideally this is a gap, so current should not be flowing in this part, right? So current should not be flowing in this part. So what should happen? So the thing that will happen is, okay, this capacitor will be started getting charged, okay, till it is fully charged. There will be a current flowing in the circuit. So even though there is a gap, ideally there should not be any current, but still there is a current. Now the explanation of this is very complex. Higher physics deal with this chapter. This chapter is one of the hardest chapter in entire physics, but because of the limitation of knowledge, because of the limitations of time, this is limited to only few theoretical concepts. One of them, the theoretical concepts given is the Amperian loop. You can consider one Amperian loop, and first you can consider this surface through which the current is flowing, or rather let me consider the top part, which will be easier. So if you consider a Amperian loop here, okay, the current is flowing through this. So if you consider this surface, okay, the current is flowing through this, and you can apply Ampere's law, that is closed loop B dot ds should be equals to mu naught I, right? So that is the B dot dl, sorry, right? This is the Ampere's law. We already learned about it. Now if Ampere's law does not specify which surface to consider, so if I consider a surface like this, okay, this is one surface, okay. Another surface that you can consider is, instead of considering this surface, you might say, okay, I want to consider a new surface having the same boundary, okay, but a different surface, like a pitcher, okay, where you store water. Or for example, you can consider that suppose I have something called a water bottle, right? Everyone has seen a water bottle, okay. So water bottle, you can consider the cap, when the bottle is closed, the cap as one surface, okay. You open the cap and you can consider the curved one is another surface. Now if you consider Ampere's law, okay, current passing through that water bottle, okay, Ampere's law is equally valid when you consider only the cap portion or you consider the curved portion. Either of them should give the exact same thing, because the current passing through that region is same, and it is crossing the surface only once. In this case it is crossing here only, and the entire surface is covered it, right? So any closed surface, Ampere's law should be valid. But in this case we can see that if you consider this surface, it is mu naught I. But if you consider any other surface, for example any other surface having the same outline, having the same common outline, okay, but if you are considering the inner lines now, then there is no current passing through this, so there is a discontinuity. But in this case, if you see, either you consider the closed one or this surface or this surface, everything has same current passing through is I. So Ampere's law is equally valid. But in case of capacitor, if you consider, okay, the outer surface, when you are considering this closed surface, current is passing through this is I. But if you consider the inner surface, okay, then there is no current passing through this. So there was a discrepancy, okay, this is called a paradox. But there was a scientist called Maxwell, not Glenn Maxwell, James Clerk Maxwell, okay, maybe some ancestor of Glenn Maxwell, I don't know that, no one actually knows. James Clerk Maxwell, he was the pioneer of electromagnetic theory, and he devised 4 equations. We will study about that in a while. But he said that because the current has to be continuous, it cannot break, in between the capacitor plates there is a current. He termed this current as displacement current, okay, he termed this current as displacement current, and it is denoted by ID. Now we will look into the nature of this displacement current. So displacement current, the source of magnetic field is not just the conduction electric current due to flowing charges, right, but also the time rate of change of electric field. So basically change, if the electric field is changing, for example here the capacitor is charging, so capacitor is charging means the electric field between the capacitor plates is not constant, but it is actually changing with time. So the time rate of change of electric field can also give rise to current, right? More precisely, the total current I is the sum of the conduction current denoted by IC and the displacement current denoted by ID. So this current, which is due to the time rate of electric field, that gives the displacement current, and the convention current, that is the flow of charges, flow of electrons, that gives rise to the conventional current or conduction current denoted by IC. So the total current in a circuit is always given by IC by ID. Now here, when we are only considering the conduction current, here in this part ID is 0, okay, and in between this capacitor plate IC is equals to 0. This is very interesting concept and potential for a very good objective question. So that's why I am teaching you this. Okay, even though this is a very theoretical and a very difficult concept to understand, they might say inside the capacitor plate which one is 0? IC is 0, ID is 0, both IC and ID is 0, only IC is 0, like that. Okay, so you have to understand that inside the capacitor plates IC is 0, ID is equals to I, whereas outside the circuit IC is equals to I and ID is equals to 0. So you have to be careful about that. Also, that time rate of change of electric field can be represented using this, where this is the electric flux link with the surface. So electric flux link with the surface, and time rate of change of that electric flux gives the displacement current. Now the flux is not constant, it is changing because electric field is changing, and epsilon naught is the free space permittivity. So based on that, assuming that there is only air, if it is not air, then it will be normal epsilon. Okay, we know the relationship epsilon is equals to epsilon naught times dielectric constant K. So these are all known equations. So this is the expression for current. Normally we do not consider this component. Most of the circuits that we are studying actually continuous current, but when it comes to discrete charges, motion of a single charge, okay, there is no proper circuit is given. In that case, this becomes very, very important. Okay, whenever there is a break in the circuit, okay, this current becomes very, very important. Now based on that, okay, Maxwell gave rewrite the 4 equations, and he was the first one who wrote all these equations one after another, and he said that these 4 equations are not separate, they are actually same form of same equations. Okay, they are linked equations. He said these equations are interconnected. Okay, so first of all, E dot dA is equal to Q by epsilon naught. This is Gauss's law. Obviously in electromagnetics we know that this is Gauss's law, right? Second equation is B dot dA equals to 0. This is Gauss's law in magnetism, because there is no magnetic monopole, so inside the surface there should not be any charges, any magnetic monopole, so it should be 0. Next is E dot dl is equal to minus d phi b by dt. So this is the Faraday's law. Faraday's law, we know that induced EMF is given by minus d phi by dt, but in case of Maxwell give rise that the induced EMF is nothing but E dot dl. He came up with this mathematics. Okay, you can once you move to the higher physics, if you study physics, you have to derive these equations. Okay, you have to link these equations so that they are making some sense. Also, B dot dl, we just learned that this is mu naught IC is the Maxwell's Ampere's equation, and mu naught epsilon naught dIE dt is the Maxwell's correction. So this is modified Ampere's equation, or sometimes called Ampere-Maxwell law. Okay, now you might see where this mu naught is coming. From where this mu naught is coming, in our previous slide, if you see, there was no mu naught, right? So from where this mu naught is coming, let us understand that. So we know that B dot dl is basically mu naught I. So this I is nothing but this. So let us put the value mu naught I. Let us put this value mu naught IC plus epsilon naught d phi E by dt. Now this can be written as mu naught IC plus mu naught epsilon naught d phi E by dt. Okay, so this is the equation that we are talking about. So there is a term mu naught epsilon naught. This term is very, very important, and we will see that actually this has some relationship with something that we will study. Now let us solve yesterday's homework. We have given 2 homeworks, a step up transformer, not yesterday, day before yesterday, because yesterday we solved PYQs. So day before yesterday's homework, these are from PYQs. So I have already solved them yesterday, still I am doing it again. If you have missed yesterday's class, so don't miss it today. A step up transformer operates on a 230 volt line and a load current of 2 ampere. The ratio of primary and secondary windings is 1:25. Then the current in the primary is. So we know that current in the primary divided by current in secondary is number of turns in secondary divided by number of turns in primary. Okay, it is opposite to that of the voltage, and how this came to be, then you have to watch my yesterday's video as well as day before yesterday's video, where I have discussed this. Now IP we don't know. Load current, I told you load current means nothing but the output current, right? That is the secondary current. So 2 amperes. Now NP is to NS is given as 1 by 25. So NS by NP will be 25 by 1. So you should remember that primary and secondary. Primary first, secondary second, that is 1 by 25. 1 is to 25. Right? So NS by NP should be 25 by 1. So IP should be equals to 25 times 2, that is 50 volts. Simple problem. 50 not volts, 50 amperes. We are finding current, so it should be 50 amperes. Right? So 50 amperes is the correct answer. So be careful, this is a very simple problem. Less than 30 seconds you should invest to solve such questions. Only thing that you have to remember is the formulas for the equations. If you remember that, you can solve it. Now this is a very interesting question. An inductor of inductance L and resistor R are joined together in series and connected to a source of frequency omega. The power dissipated in the circuit is. So power dissipated in the circuit is VI cos phi. Okay, so what is V? V is V, because options are given in terms of V. I is V by R, right? Cos phi. Instead here, because we are using inductor and resistor, so it will be Z. Okay, this will be Z. You can consider C as 0, so it will be V square by Z cos phi. So what we need to find? We need to find Z, we need to find cos phi. So what is Z? Z is square root of R square plus XL square. What is XL? XL is omega L, right? These are all known things. I hope this is having a good revision. So that's why I always solve the problems in our next classes. So R is R square plus omega square L square, right? This is the value of the Z. Now cos phi is R by Z. Okay, so let's put these values. V square by Z times R by Z, or V square R by Z square. So what is Z square? Is Z square should be the same thing without the square root, right? So let me write that. So it will be R square plus omega square L square, right? So this is the answer. So V square R by R square plus omega square L square. This is the answer. Now let's move on. Speed of light, very very important. We know that speed of light in free space is given by C is equal to 3 times 10 to the power of 8 meter per second, and this is a constant, right? This is a constant, it does not change. It can be changed when the medium is changed, or we are using different colors of light, but in free space all colors of light moves with the same speed. Okay, you should remember that all the colors move with the same speed in free space. That is, in vacuum all the colors move with the same speed, but when it changes medium, the colors tend to move with a different speed based on their wavelengths. Now the speed of light in terms of electric and magnetic field is given by, I think I have told you this formula, C is equal to 1 by mu naught epsilon naught. Okay, if you calculate, if you put these values, then you should get the value of 3 times 10 to the power of 8 meter per second. These are all constant. So in free space, this is the speed of light. Also, if the electric field is given by E and corresponding magnetic field is given by B, then the ratio of E by B should also give you the speed of light. So basically electric field and magnetic field, they are not independent. So this chapter is trying to establish that electric field and magnetic field that we have studied so far as independent concepts, they are not so independent. They are linked together, and they are linked by the speed of light. So speed of light is the glue that is binding electric field and magnetic field. Now not always they are together, even though they have some relationship. We will see that in a while. An accelerating charge is a source of electromagnetic wave. Now electromagnetic wave, we are coming to electromagnetic wave. Now what is the role of an accelerating charge? An accelerating charge can produce a time varying electric field, that is the electric field which changes with time, and it can also produce a magnetic field which also changes with time. Normally a static charge, if the charge is static, it can only produce a electric field which is constant. Okay, if the charge is moving, it can produce, if the charge is moving with a constant speed, okay, it can produce a magnetic field, but that magnetic field also constant in time. So constant in time has nothing to do with electromagnetic wave. Electromagnetic wave, where it has to change, right? Wave has to have some time component. So as long as there is a time component involved, then only electromagnetic wave is developed. You remember the wave equation, we will see that in a while. So that wave equation, where you are studying wave equations has a omega t term, sin omega t plus some value. Okay, so that omega t term is basically that changing the magnitude of the wave. That's why the wave is changing, and there was one more term involved, that is taking the wave forward. So both are there. Now if you consider, accelerating charge produces mutually perpendicular electric and magnetic field. This is also important. Okay, so they not only produce electric and magnetic field, these electric and magnetic fields are actually mutually perpendicular. And if you see, this is electric field, okay, this is the magnetic field. So there is a charge in motion, and when there is a mutually perpendicular electric and magnetic field, there is an electromagnetic wave. Now electromagnetic wave will be propagated in this direction. Okay, electromagnetic wave is generally E cross B. Electromagnetic wave direction is E cross B. So if you cross product, E cross B means you have to start with E, you have to move your fingers towards B, whatever the direction of thumb, that is the direction of the wave. So E cross B should give you the direction of the wave. Okay, we will study in a little bit more about this in our chapter dual nature of radiation on light and matter. There you will explain, we will explore a little bit more some more problems on this chapter. Okay, but so far this is sufficient. Now if I take electric field produced by the moving charge to be E0 sin kz minus omega t. So kz is the direction of propagation. So electric field is propagating along z axis to in the z axis. Okay, and this time varying term is changing the magnitude of electric field. So that sinusoidal wave is being formed. Now corresponding magnetic field, the linked magnetic field will be sin kz minus omega t, but the value of B will be different and the direction will be different. Remember that. So even though both of them are sine, in fact if you see both of them are sine, this is y component, this is x component. So they are moving in a different direction. So electric field is changing in this direction, x and x direction, whereas magnetic field is changing in the y direction. Now while we are drawing x, y, z in 3 dimension, we generally draw x along this direction, not y. Y is along this direction and z is along this direction. These are the common practices you should know. So y is basically in and out of the paper. Okay, z is on the right hand side and x and y is, x is on the like this. Okay, so that x cross y should give you z. So x cross y should give you z. So this arrow represents out of the paper. Okay, 3 dimension. I cannot draw 3 dimension in a 2 dimensional board, but still you can think it as a 3 dimensional line, so which is basically out of the paper, right? Here k is very important. K is called wave number. Okay, k is called wave number, and it is related to wavelength like this formula. K is basically omega by c. Also 2 pi by lambda. If you remember the wave equation in the past where you have learned y is equal to some amplitude sine 2 pi by lambda, okay, x minus omega t. That was the wave equation, if you remember. Now this term 2 pi by lambda is called wave number. This is wave number and denoted by small letter k. Okay, so if you still remember that, fine. Otherwise, when we are revising the chapter waves, I will try to focus and try to make you remember this formula. Okay, now this, based on these formulas and these equations, multiple questions came in your previous year questions. Now the proper so the wave propagates in the direction of E cross B. So as I said, the wave propagates in the direction of E cross B. So when you do the cross product of E cross B, you will find the direction of motion, right? Now this is very important in terms of your PU board, in terms of your concepts, in terms of even KCET also. This chart you have to remember which one has higher frequency, which one has higher wavelength. So these are the things that people often confuse. You should remember gamma rays, okay, gamma rays, X-rays, ultraviolet rays, they have very high frequency. Okay, these are high frequency and they have very low wavelength. Okay, gamma ray, X-ray, ultraviolet ray, they have very low wavelength and very high frequency. So high frequency means low wavelength. So relationship between wavelength and frequency are inversely proportional, right? As you know, C is equal to nu lambda or V is equal to n lambda, right? In case of light, when we are talking about light, that V becomes velocity of light, that is C. That's why I have written C is equal to nu lambda. Nu is the frequency and lambda is wavelength, as you know. So frequency for lights which are above, they have very high frequency, whereas wavelength is high for whichever is lower. Okay, so wavelength you can consider as mass. So higher the wavelength, they are heavier, they are at the bottom. Okay, lighter it is, it has higher frequency, upper it is. Okay, they are vibrating, they are like childs, they are kids, they are vibrating very fast. Frequency means they are vibrating very fast. So they are like kids, they are up. Okay, and they are very dangerous. Okay. So gamma rays, X-rays to be already familiar with. If you have ever had a broken bone, then the doctor might have done an X-ray scan on you. So maybe you are familiar with X-ray, right? So X-ray is one of those rays. Ultraviolet ray is also very common. If you have seen those lights, some bluish light which is used to check whether a currency is a duplicate or not, forged or not. Sometimes it has some violet ray mixed with it, so it is visible. Otherwise ultraviolet ray is not visible to our eyes, but it the notes that we use, currency notes, they can detect ultraviolet ray and show us some hidden secrets inside the notes. Now after ultraviolet we have the very small region that consists of our entire universe. In our entire universe, whatever we can see is lie only in this small, very small region of electromagnetic spectrum. So when an electron moves with the speed, very high speed, accelerating, it produces wavelengths. That wavelength is called electromagnetic wave. Now that electromagnetic wave is basically part of our vision also, that our eyes can detect them. Okay, some of the part of that electromagnetic wave is produced by the accelerating electron. Accelerating charges can produce light. That light is being produced and can be detected using our eyes and by some machines also. Now the part that we can see of the entire electromagnetic spectrum is very small. So from for this chapter, instead of calling it as a light, we will say electromagnetic spectrum. Electromagnetic spectrum is the entire series, entire family. So if you have brothers, cousin brothers, your mother, your Dodamma, Dodappa, etc., they are brothers, like that. So they are all part of this family. Okay, this is the larger family. Out of that, your family consists of your father, your mother, you and your sister, maybe. Okay, so that is the small part, right? This is the small part that is visible to our eyes. Other than that, all the other parts which are not visible still part of the electromagnetic spectrum, and we have certain devices, certain instruments that can detect them. Obviously X-ray machines can detect X-rays, gamma ray machines can detect gamma rays. Gamma rays is used for cancer treatment. Okay, ultraviolet rays are used to detect counter forging, that is currency. Also ultraviolet rays are used to sanitize things so that there is no virus or bacteria is present. So ultraviolet ray can kill germs, so that is also used for ultraviolet rays, especially during surgeries to sanitize the instruments which is used to do the surgery. So that is one of the part. Visible ray is the part through which we observe. Okay, the topmost part that we see is violet. Okay, violet is the highest frequency but lowest wavelength in the visible spectrum. So wavelength is around 400 nanometers. Okay, frequency you can calculate. Frequency range is given here, around 10 to the power of 15 hertz. Okay, so wavelength is 400 nanometer for violet. Now next is indigo. Indigo is not shown here, but most prominent is blue, then green, then yellow, then orange, then red. Okay, so here all the colors are present except indigo. Indigo will be somewhere very close to violet. Okay, so violet, indigo, blue, green, yellow, orange, red, these are the part of our entire world. So entire world that we can see is only basically this much. If you see in terms of wavelengths or even in terms of frequency, the part that we see is only very small. So most of the part we actually cannot see. Okay, be it in ultraviolet range, be it in the higher range, higher wavelength range, we cannot see that. Okay, our eyes are not suitable to watch that. Some animals can see infrared rays, some animals can see ultraviolet rays. Okay, so for example the nocturnal animals, okay, like the birds who prey at night, they can see in infrared. Okay, infrared rays is emitted during night. There are some goggles discovered by humans, they can detect infrared rays. Okay, infrared ray is infra, that is lower than red. Okay, and ultra means higher than violet. Ultraviolet means higher than violet, infrared means lower than red. Okay, so basically infrared is having wavelength higher than red, but actually it is situated below the red light. Okay, so frequency is low, so that's why it is below the red light. Ultraviolet has higher frequency but lower wavelength, right? Now next is microwaves. If you are using that in your home, you should remember that that is also an electromagnetic spectrum, and yes, the microwaves actually use real microwaves, so you should not use it while opening the doors. That may be harmful to your body if they are coming into contact directly with your body. Microwaves react with water, and they can heat up water molecules because of the conversion energy transfer. Okay, so if you are using microwaves live in your hand, then the water present in your body, as you know, human body is 90% water, it may react with your body and your body will heat up and you might die. So never use microwaves with the door open. Now short radio waves, there are different types of radio waves. So if you are born much later, but that time if the radio was still available, but nowadays only FM radio is available, other than that no other radios are available. But if you are living in a rural place, in a village, and if you are listening to Prasar Bharati or any other distant channels, they are basically short radio waves. They are directly being transmitted from Delhi. Okay, there are television and FM radio. Okay, television, nowadays we are using dish antenna or set-top boxes. Previously there used to be normal antennas. Okay, so that television radio waves are already gone. Okay, you do not use that television waves anymore. There are different kinds of television waves are used nowadays. Okay, it is almost same as FM radio. Okay, only frequency range is slightly different. So FM radio we are all familiar with. Okay, there are different channels available on FM radio. If you tune it to that channel, you will see different songs, different shows, right? Next is AM radio. AM radio also part of radio wave. Okay, it is also used to be radio, but nowadays if AM radio is only for military communication, no longer available for us because it is obsolete and it gets distorted very soon at a distance. So AM radio is also not very popular anymore. And long radio waves, for example, when elephants are communicating with each other, okay, different elephants, herds, they can communicate with each other by tapping their feet, okay, that is an example of long radio waves. Okay, they can send signal. If some herd is there, suppose 1 kilometer away, they can detect that and they can respond. Okay, there are also long radio waves can be detected from stars outside our solar system. You can detect long radio waves. They are also a way of receiving signals from those very distant galaxies which may be otherwise not visible to us, right? These are different types of waves present in the electromagnetic spectrum. This entire thing is called electromagnetic spectrum or electromagnetic family. So you should be familiar with that. Very few questions sometimes come from this. Which one has higher wavelength? Which one has higher lower wavelength? We will see that in a PYQ section as well. Okay. So if you remember that, then you should be able to answer that. Now this is a shortcut synopsis of everything. Okay. Radio wave has a wavelength range of 0.1 meter. 0.1 meter is actually 10 centimeter. Right. So 10 centimeter is like the 10 centimeter in your scale, which is a very high distance, right? Rapid acceleration and deceleration of electrons in aerials, okay, receivers aerials, okay, and microwaves is from 0.1 meter till 1 millimeter. Okay, so there is a crystal, okay, klystron valve or magnetron valve. Magnetron is the one which is used in our day-to-day waves. Point contact diodes can detect them. These are the few information bytes that you need to remember. Infrared has a wavelength range from 1 millimeter to 700 nanometers. So this is a very large scale distance. So you can imagine 1 millimeter, starting with 1 millimeter, that is the smallest distance in your normal daily scale. That is the normal ruler that you use, that for small 1 millimeter till 700 nanometer. Right, so it is a huge distance. It can be vibrations of atoms and molecules. Okay, thermopiles, there are bolometer, infrared photographic films, they can detect infrared. Okay, light, normal visible light. Okay, this is visible light. Okay, and it has a range from 700 nanometer till 400 nanometer. Okay, electrons, atoms emit light when they move from one energy level to one energy level, right? They can be eye photocells, photographic films. They can all detect normal visible light. Ultraviolet ray is from 400 nanometer till 1 nanometer. So now we are going very low distance. Okay, wavelength is very low. Inner shell of electrons, atoms, there are different reasons given why it is produced, and photocells and photographic film can detect it. Okay, X-rays are very smaller, much smaller in wavelength. That's why they can penetrate our skin and they can photograph the bones, right? The X-ray tubes, inner shell, there is a special mechanism called X-ray tubes. They can produce X-rays. Okay, photographic film, okay, Geiger tubes, ionized chamber, they all can detect X-rays. They can also detect gamma rays as well. Okay, gamma rays is generally produced by radioactive decay of the nucleus. So any nuclear power plant, even though they are very protected, they are stopping the gamma ray to come out. But like if you remember, Chernobyl was a disaster where the nuclear reactor busted and all the gamma rays came out, and there was a disaster and many people died because of that incident. So that is one of the incident where gamma rays were people were not able to contain the gamma rays. Okay, and also the radioactive emission. So this is one of the reason that gamma is very harmful, and with a controlled way it can be used to treat cancers. Okay, cancers can be treated using gamma rays. Now let's look into the previous year questions. So we will be solving all the previous year questions from this chapter. First question: the ratio of magnitude of electric field and the magnetic field in the electromagnetic wave is in the order of. So basically electric field divided by magnetic field. Electric field divided by magnetic field is equals to C. So the order should be 10 to the power of 8 meter per second. So you should be careful. E by B is C. Sometimes if they ask you the question, what is the ratio of magnetic field divided by electric field, or what is the ratio of magnetic field to the electric field? So in that case it will be 10 to the power of minus 8. So no doubt about it, whether it will be 10 to the power 8 or 10 to the power minus 8, but what will be it? So if you are confused, you should remember E by B is equal to C, right? Now, which of the following radiations deflected by electric field? So this is a partially deleted question. Gamma ray has no charge, so it will not be deflected by electric field. X-ray is also electromagnetic radiation, so it will not be deflected by electric field. Alpha particle will be deflected by electric field because it's a positively charged particle, and neutrons will not be deflected, it is also neutral, right? Now, which of the following radiations of electromagnetic waves has the highest wavelength? So I was telling about it that you have to remember the chart, and from the given information you have to answer which one has highest wavelength. Now, infrared rays is less than red waves, so it is a high wavelength. X-ray is obviously not high wavelength. Okay, infrared ray can be a candidate. X-ray is definitely not, UV ray is definitely not. If it was said that which one has the highest frequency, then definitely UV rays or X-rays rather will be the candidate. But microwave even has higher wavelength compared to infrared rays, so in this case it will be microwaves. But if radio wave was there, then radio wave would have been higher than microwave, so radio wave would be the answer. So you have to choose from the given option which one has the highest wavelength. Okay, be careful, read the question, it is saying wavelength or it is saying frequency. So based on the option you have to answer this. Now, suppose that electric field amplitude of electromagnetic wave is E naught equals to 120 Newton per Coulomb, and its frequency is 50 megahertz. Okay, then which of the following value incorrectly computed? The magnetic field amplitude is 400 nanotile. So let us calculate the magnetic field. So magnetic field will be electric field divided by the speed of light. So magnetic field is 120, electric field is 120, and magnetic field will be 3 times 10 to the power of 8 Tesla. So 40 divided by 10 to the power of 8. So 40 divided by 10 to the power 8 can be written as 400 to the power 10 to the power of 9 Tesla, or it is 400 nanotesla, right? So magnetic field is correct. So this is obviously not the correct option. They have asked you which of them is incorrect. So this is correct, right? This one is correct. Angular frequency of electromagnetic wave is pi by 10 to the power of 8 radian per second. So frequency is given 50 megahertz. Mega means 10 to the power of 6. Now we know that in our previous chapter AC, if you remember, we have learned the relationship between angular frequency and linear frequency. It is 2 pi f, right? So angular frequency will be 2 pi times 50 times 10 to the power of 6, right? So 50 times 2 will be 100 pi times 10 to the power of 6, or we can write this as pi times 10 to the power of 8 radian per second, right? So we can convert it into angular frequency. So this one is also correct, this was is also not wrong. Propagation constant, angular wave number is 2.1 radian per meter. So what is the propagation constant? We know that propagation constant is k, which is 2 pi by lambda, right? Or also we have learned that this is nothing but c by omega, right? C is 3 times, omega by c, right? If you remember the formula, it is omega by c. Omega is pi times 10 to the power of 8. I think I am using enough space, so let me use this space for now. So k is omega by c. So omega is pi times 10 to the power 8, we have calculated. C is 3 times 10 to the power of 8. 10 to the power 88 cancels, omega is 3.14 and this is divided by 3, so it should be around 1.12, 3 4s are 12, so 1.4, around 1.4, right? But the value is here given is 2.1 radian per meter, so this is incorrect. It should be around 1.4. So which one is the incorrect? This is the incorrect one. Okay, you can check the wavelength also. Wavelength you can calculate using K, or you can using any other formula. Okay, you can use relationship between omega and F to calculate wavelength, and it will come out to be 6 meter. We are not checking that, okay, because we have calculated that this value is obviously incorrect. So this should be our answer. Now, the source of electromagnetic wave can be a charge. So when a charge can produce electromagnetic wave? Moving with constant velocity? No. Okay. Moving with a circular orbit? Maybe. At rest? Definitely not. Moving parallel to the magnetic field? Obviously not. So correct answer is moving in a circular orbit. Now let us understand why moving in a circular orbit is actually can produce a electromagnetic wave. An electron moving in a circular orbit, okay, it has a acceleration. Okay, it is called centripetal acceleration. So this electron is always moving with an acceleration because its velocity, direction of its velocity is changing each and every point. So if you remember, we have done that part in our PU1 in the class. So that point of time we have learned that the speed is velocity is changing, so there has to be some component of acceleration acting inside that acceleration. We termed it as centripetal acceleration. Because of the centripetal acceleration, electron is not moving with a uniform speed. Electron is moving not moving with uniform velocity. Electron is moving with an constant acceleration. Because it is moving with a constant acceleration, any accelerated electron can produce a electromagnetic wave. So this is a accelerated motion. So many people often forget that circular motion is actually an accelerated motion. Okay, now an electromagnetic wave is traveling in x direction with electric field vector given by E is equal to E naught k x minus omega t j cap. The correct expression for magnetic field vector is, so electron wave is traveling in x direction. So electron wave is traveling, electromagnetic wave is traveling in x direction. So let us understand that electromagnetic, this is the direction of velocity. Electric field is along y direction. Electric field is along y direction. So what, this is E. Now if this is the direction of E, okay, E cross B should give us the direction of speed, that is speed of light. This is the electromagnetic wave propagating in this direction. So first of all, we know that this should be upwards. That is the direction of our electromagnetic wave. Now along the x direction is our electric field. So which direction should we rotate our fingers to get the magnetic field? So magnetic field should be somewhere in this direction, right? So magnetic field should be in this direction. Okay, electric field is in this direction. So basically what is happening here is electric field is along this direction and magnetic field is along this direction. So if you do the cross product from here to here, you will get the direction of electric field, right? So from there we can say that magnetic field should be along z direction. So this is clear, right? Positive z direction. Magnetic field should be along the positive z direction, and we also know that E by B or E naught by B naught, because it is other term will be cancelled, sin kx by omega t should be constant, so they will cancel each other. So E naught by B naught should be equals to C. So B naught is nothing but E naught by C. Okay, so B naught should be E naught by C. So correct answer is this, E naught by C sin kx minus omega t k cap, right? This x represents the direction of electromagnetic wave. Okay, this is the time varying magnetic field, and it should be along the positive z axis, right? And this should be the answer, right? Now let's move on. Electromagnetic radiation used to sterilize milk is obviously UV rays. I already told you that electromagnetic radiation which is used to sterilize is UV rays, not X-rays, not radio waves, not gamma rays. Okay, it is UV rays. Now, if E and B represents electric and magnetic field vectors of an electromagnetic wave, then the direction of propagation of a wave is along E cross B. I told you this also. So E cross B is the direction of electromagnetic wave. So E cross B should give you the direction of electromagnetic wave. This is the last question. A plane electromagnetic wave of frequency 20 megahertz travels through space along x direction. If the electric field vector at a certain point in space is 6 volt per meter, what is the magnetic field vector at that point? So basically we know that electric field divided by magnetic field should give you the speed of light. So don't worry about the frequency. Frequency is not important. So magnetic field should be equals to E by C. So this is a very common formula. I have seen that 3 or 4 times in last 10 years this formula based questions came, right? So electromagnetic field is given 6 divided by 3 times 10 to the power of 8. So cancels. It will be 2 times 10 to the power of minus 8 Tesla. So 2 times 10 to the power of minus 8 Tesla. This is the answer. Now if you want all the lectures at one place, all the videos are uploaded to our channel, to our playlist. You can go and visit this playlist, and each and every video that we are doing for KCET 2025 is available here. You can check here and you can download or you can save this. Please bookmark this part. Here you will get a notification whenever new video is uploaded. That is every day 9 PM. So one video is getting uploaded, and once it is done you can get the notification in our WhatsApp channel as well. You have to follow our WhatsApp channel. The link is given in the description. You will also get the entire class notes available in the comment below. You can check there. Also you can check in the description box. The note will be given there. You can download it and you can study from there. But please share it with your friends if you think this is helping you. Also please subscribe to our channel. Thank you for watching.